Hello guys, so in our last video we talked about section table, like we find the entry point and we found that whether the section is executable or writable. Today we will gonna load DLLs so that we can see when a binary get executed which DLLs is loaded into the memory. So I tried it. First, I tried it in the hard way, and I crashed my Windows like couple of times, 20, 30 times, because I was parsing the binary in the disk. So I learned in the hard way that you can't parse a DLL, sorry, a binary in the disk, just because of the two reasons. Because if I increase the size from like 5, 6 KB, my Windows get crashed. Another reason was that the offset in the a binary is relative to the base address, and when the binary is on the disk and not mapped to the memory, so every offset is just useless. It will point to the garbage, so it won't make any sense. So before start, and there are like two things I want you to let you know, that there are like two kind of DLLs we're gonna like see today. One is like static, another one is like dynamic. So whenever a binary is like compiled, compiler tells it make a export table that this DLL, this binary will use. We're gonna export that also, and another one is dynamic, which DLL which gonna load at the runtime. So why an EDR need both? Because there is a thing called like dynamic API resolution, which you can use load library and get proc address, and you get address to the DLL, and you can load a DLL at the runtime. So first we'll load dynamic DLLs, then we're gonna load like static, and we will compare if there are like miscommunication between them. Like if a binary say I will load this DLLs and some DLLs load after using some dynamic way, then that's a suspicious thing. And thing is most of the Windows binaries also use that. So we are just checking if the static binary say we will gonna use this DLL, and some DLLs they didn't define and they are also calling them. It's like suspicious thing. So we're gonna use that. Last time we use process creation callback, this one, and same thing we're gonna use. Let me close some history and let's start. So this is the what we say workflow of the today's video. So I will just look at this function, and you're going to see that this give us a callback whenever a DLL or executable loaded into the memory. So we have to use that, and in order to use that we need this function also. If I go here, so basically we need these three things to call that load memory function, and this is also same as the notify function. So we will create another function here, void notify, let's call it image, and we will call add this parameter. So first is optional, and optional means it can be null. So let's write this, and I will call it like image name. So what it gives the full path of the DLL when it get loaded into the memory. So I will use this, you will gonna see what it will show, and it gives the dynamic DLLs which loaded into the memory at the runtime. So another thing is process ID, so I will just copy this and paste. Another one is like p image info. So I will just write this. So we created our function, and so now we can call the image memory notify. So let's copy this function, and we will have to call in our driver entry, and what's the name? Image notify. It takes a return value as a status, so we have to write a status here, and we also have to check the status. So let's just copy paste this and change the name. Just like our process creation, we unloaded that function. We also have to unload a load image notify. So Microsoft provided a function here. By using this, we can unload the function. So let's here copy paste this, and we are done. So now we can focus on notify image. So we are not using this for now. We will gonna use this in our later video, and let's call this so that we can compile our function neatly, and just log it everything, and we're gonna log, call it norm, and we're gonna just uh, say like this: image loaded PID and image name. Let's call it DLL. And so we have to now pass the parameters. Let's copy this and paste. Another one is image name, copy paste. So we are done, and let's compile this and see how many errors we will gonna get. Paste, build, and nothing. So let's load into our system. It already exists. So I have to delete, create, start, and we will gonna open debug view. So you can see so many DLs loading at the runtime. If I open a calculator here and stop the EDR for now, also stop the kernel because some notification always will come. Where is calculator? Here is it. So you can see the PID of the calculator is 4536, and there are some DLLs loaded by calculator 4536. These are the DLLs. If I go here, and you can check the first is like the binary itself, and the another one is like 456. Here is the DLL kernel, 32 DLL kernel base address, sorry, base DLL, so many things. So you can see the DLLs which is loaded at the runtime. So now we have to check the static DLL. So for that we have to make another function. Last time we make alpha, so now we will create another function, boolean alpha image. To use this function we need this thing, so I have to explain it first. So in this function you will get a base, image base, and image size. Image base is like the starting point for of the memory, like a binary get. So that means when a binary get executed, it get loaded into the memory. Image base means the base, the starting point of the memory, and image size is defined the size of the memory it get allocated. So by using this, we can get the whole size, the starting point and ending point of the memory. If we add image base plus an image size, we will get the whole like starting point and exit point, sorry, starting point and the end point of the memory. So that's why we use this function and this structure and these fields. So we have to change this because we are going to use this. and we can see it's a null pointer, sorry, pointer to void. Another one is size. So before calling anything, we have to check each and everything so that our like windows don't crash. So I will just check if image info field name is image base is null, or we can say image info size is equal to 0. That means we are like doing some cross check things before like even loading things into memory. So we will just return false. Return false. No. It's like void function, so we don't have to return anything. Now we can save things in a variable. So p void, the void of the, what do you say, image base. So we can just call it base, and we will just copy this and paste. Another thing is size t. Let's call it size, and we will gonna copy this and paste. So we pay like we created this functions, sorry, these variables. Now we can pass here. So thing first thing is like p void. So we'll call it p void base. Another thing is size t. So we will call it size. Now our function is started. So same thing we have to check before like going to the function. So we will check if base is null or size is equal to 0. Then we will return false and exit the function. Now we have these things we have to change the things, change the variable. So we start with base. So we will call it start because we need a starting point of the memory. So I will just call it bchr, and base, we have the starting point now, and we have to now get a ending point. So we will call it end, and we will just add start plus size. We have the ending point. So now we are in the memory. In the memory, same thing we have to do. Last time we were in the disk and we resolved the anti-header, and same thing we will gonna do here. We are not actually using the anti-header in the like in to resolve the DLLs, but we need a confirmation that we are passing the binary like correctly, so that we won't make any mistake, because anti-header some signatures we can use that. So here is the notes. We were here and now we have to reach here p image anti-header. Just like our last video, we will call it anti. And this is like to reach that, there is a undocumented function by Microsoft. And why it's called undocumented function? Because Microsoft tend to change those function by like given updates, but like they are not like changed like in past 15 years, but it can. So it can crash your Windows. So be careful while using it. So if you give the like anti image anti header the base address, base pointer, then it will just give you the anti header, and we can check by the if statement, like if anti is null, or you can say like anti signature is equal to not equal to image anti signature. So if this thing happens, so we can just say that anti image sorry, RTL image anti header just failed. So I will just log just print on the debugger view is failed, and I will just exit the function by returning false. So we checked if things goes like we predicted. So we are in now like headers section of the binary which is loaded into the memory. So now we have to reach here image import descriptor. So what it is? So it's also like not very defined or very good documented by Microsoft. So it's just like an array, like there are so many descriptor, and each descriptor will point out to their functions, which binary says. For example, I was here in static, like compiler tells me that this array we have to load while like executing the DLL, sorry, executing the binary. So this is the structure where it stores. So it contains the name of the binary. It contains the first thunk means you can say the function they will gonna use, and there's another function here, original first thunk. So these are the things we will gonna understand in depth when we import functions. In the debug view we can see which function the DLL is using. So just forget it about it right now. We just focus on the name. So what does name field contains? It contains the pointer to the string of the DLL name. Simple as that. Name field contains a pointer to the name of the DLL. That's it. Simple as that. So that's why we are using this structure. So we have to reach here. So for that we're gonna create a pointer to that. I will call it IMP, and we're gonna use this function and it's also like undocumented and very risky function. Let me show you something before I move forward. You can find some article that this function cause so many BSOD, so be careful about it while using. So this function name is not the same we are using, but the data types, so fields, parameters are the same. So we're going to use this here. So we have the base, yes. Another thing, mapped as image, yes. Images like our binary mapped as image. Data entry we need import. Here is it. We just copy paste. Another thing is size means it's like give the output of the size of the DLL. So we have to create another variable long. Let's call it uh, directory size, and we'll make it 0. So and it's a pointer, so we have to use as it a pointer. So where is the, so I will just use uh, size. So everything runs fine, I guess. So we can just check if uh, our pointer to the structure is empty, or we can say that dr is equal size is 0, then we can just exit, or we can just log at things like log, and we can say this function failed. And we return false and exit the function. So now the thing is, like I told you, this whole thing is like an array. So each DLL have this structure. It will tells the function, the binary defined before, like while compiling, and the name. So it's like a bunch of arrays, like this array, like kernel 32.dll have this array. So many things, like bunch of DLLs have this array. So we're gonna move from one array to another array to another array, and we will gonna get the name of it, of each DLL. So for that I will just start a loop, and first thing we don't need our first parameter, first condition. So I will just write this, and I will use the name, and I will just increment the array here. So we have all these things right now. So now what we have to do, we have to check that our this structure is inside the memory or not. If the thing is not inside the memory, your system will crash. I crashed so many times, so that's why I'm saying You have to check things before you even do something. So we have to check that this structure is in our memory or not. For that, we have to change the data type first, and we will call it here. And if is greater, the start is greater than him, then it's like behind the start. Or we can say if let's copy this. I don't want to type uh, plus size of this structure. If this both things are like outside the memory, then we will just exit. We don't need to proceed. If like we proceed, our system will get crash. So first thing, don't make the mistake here. We have to take the size of the structure, not the pointer to the structure. So if it's greater than the end, then we will gonna just break the loop, and we will continue about it. Now we have these things. We check that the structure is inside our the memory we got allocated. So now we have to add the name. So let's make a variable ulong, and let's call it name ADR. And here we can just like write here. Now this address points to the what we say, to the memory. Sorry, not the memory, the name of the DLL. So we can just say like if uh, name address is equal to 0, then we can just continue. We don't want the loop to stop. Continue. We are doing this because sometimes the name section, the pointer can be 0. If it becomes 0, then it will like stop thing, and we won't be able to get every real name. So that's why we are doing this. Now we have to like let's point to the what we say name of the structure. So we are using future, and let's call it DLL name, and we will gonna use the starting point plus the pointer to the structure DLL name. And still we have to do it again. We have to check that these things is inside the memory or not. So we will gonna use this DLL name less than start, or DLL name greater than end. If it's happened, then we will gonna just break and get outside the loop. If everything runs fine, then we can just log out the DLL name 12345. I will just call DLL and percentage S, and that's it. And here's DLL name. So loop like the loop for loop is finished, and we have to return something for the function. Because it's a boolean function, we will return true. So we created our function. Now we have to like call this function in notify image. So for that, hmm, everything looks fine, I guess. Let's like it will create so much noise, you won't able to see things. So that's why I will uh, use these things so that we can see the static TLLs. Just copy paste. Now we can see clearly, and let's call the function alpha image, and we will call pass the base and size, and we are done. So let's check how many errors we will gonna see today. I guess no issues found. That's amazing, I guess. Let's build it. And the thing is like these two functions I told you is like undocumented by the uh, Microsoft, so we have to define it before like compiling the driver. So which was the function? The first function was this. Sorry, this is the first function. So we're gonna have to define this. Copy. We will write text turn. See, we're gonna paste this and delete all of this, and it's a pointer to void, so we void. That's it. First function is done, so we have to do same thing for another function, and here is it. Just copy and paste, and let's just copy paste things from here only. So we will just copy paste this, and let's copy this. So we have to write out because it's giving output, and that's it. Let's see if our function is being compiled. Sorry, our driver is being compiled or not. Hmm. We are making so much mistakes. Let's see. Okay, now it's done. Let's build it, and our driver is like running, so we have to stop it first and delete the driver. Let's compile it. So it's done. Let's load into the system and start now, and we have to see what we'll see on the debug view. So you can see so many like if I wait a second, if I open a notepad, wait a second, again I have to do, like so much noise comes, and later on we will reduce the noise, and this is just a raw data and we have to convert the raw data into information. So in the next video we're gonna do that. Let's close this and notepad, and we have to stop our EDR so that we can read things. So these are the DLLs defined by the compiler while it's while the binary was compiled. So these are the sub particle, sorry, sub DLLs, which is necessary to run the main DLL. So don't get confused, and it will show you bunch of data. So next video, if you like in the next video, what we're gonna do, we're gonna compare these things, like if uh, a static DLL should be equal to the dynamic. If they are not equal, then DYNA MIC. So if they are not equal, that means someone is using like a load library and get proc address. So that's it. That's for the today's video. I hope you like this video. I humbly request you guys, please like and share and comment, because it takes so much time to create a video, to learn things in depth, and I'm like spending so much time crashing so much windows, and like fighting with myself alone, because each like each thing like start like simple, but it get like so wild. There are so many loopholes, like tree, one thing leads to another thing, to another thing, to another thing. Is like like I'm going inside a void and I'm finding nothing, but I'm trying my best to like learn for myself and learn for yourself. And the main purpose for like making this video so that everyone can have the free EDR. There should be no monopoly. And second thing, that I am a malware developer and I want to learn that how an EDR works so that I can make a better malware. I guess that's it for today. Thank you for watching this video.